All right, welcome everybody. My name is Andre on behalf of ASCILITE. I'd like to welcome you all and welcome Colin, which we very much appreciate doing this session today for us. Just a brief introduction before I hand over the mic to him. He's an educator at Deakin. He's been working across many roles over the last 20 years in teaching, research and admin, and he's a senior lecturer in the School of Medicine since 2012. Where he manages the eLearning team that is supporting the use of technology there. And of course, he has been a member of the cARdiac ECG team and involved in the initial development of the project and particularly the Learn and Assess modules. And today we're very happy to have him explain to us the app, the mobile app, and hopefully we'll get a little bit of a demonstration of how that works. So no further ado, I'll hand over to Colin. Thank you.
Turn off mute. Hi everyone, and thanks for the introduction, Andre. I see there's some friends in the audience, so that's lovely. But thank you very much for having me along. I need to acknowledge the invitation from ASCILITE as the winner of the Innovation Award at last year's conference. I've been invited to write a blog post, which came out just over a week ago, and do this webinar. And I'll also get an opportunity to talk to the cARdiac ECG app and other developments in the school at this year's conference. So hopefully see a lot of you there. In Geelong. Be great to have it here in my hometown. Save me a little bit on accommodation and travel, I guess. But let's get going on the story of cARdiac ECG. I will keep an eye on the chat stream, so if there are questions, happy to answer those. Maybe save them till in between my short presentation and then doing a demo of the app itself. So that'll be a test. Andre and I've had a trial, seems to work okay, and hopefully that'll work for us later on. So I guess cARdiac ECG started in the School of Medicine here at Deakin, and I wanted to acknowledge the team. Karen D'Souza and Sarah Burgess are our subject matter experts working in our doctor and patient theme and responsible for the teaching of things like ECGs to our students. And Peter Bright, who's on our eLearning team, who's an online curriculum coordinator, has been very helpful, active member of ASCILITE as well, and a helpful member on our team. I also need to acknowledge our eSolutions division. They provided project management for the project and also the funding dollars. And Eon Reality, who were the software programmers for the app. The background to the story was that we noticed that our students were struggling to, I guess, understand the complex relationship between what you see in a 2D trace on an ECG, that's those squiggly lines, as laymen call them, and what's happening in the heart at the same time. So translating that 3D heart action, there's muscles pumping, there's valves opening and closing, and there's electrical impulses floating around. So how the students understood that, we realised that they were having difficulty learning from textbooks. We developed something called ECG of the Week, and that was in our LMS, where students could have a look at an ECG chart, a trace, and try and interpret what was happening in the heart, and then providing an answer, and then being able to see an expert analysis of that. That was very well received initially, lots of hits, but after a month, 5 weeks, things really slowed down, and I guess students have moved on from ECG and they're learning something else again. Then we thought, let's try some extra in-class sessions, hands-on with tutors to help them do that. That also helped a little, but it was still a wicked problem, and the university was playing around with AR and using it in our marketing, so for open days and things like that, having some augmented reality experiences. And I sort of asked, why aren't we using this for teaching and learning? And they said, well, have you got something to do? And we said, we sure have, this wicked problem. And they said, okay, write up a project scope, which we did, and that they came to us with some funding, and off we went. So we had the problem we were trying to solve. Then we thought, how can we best use AR? And that was thinking about that 3D model of the heart along with the 2D trace in sync. I guess that's what we were looking for. And then developing some sort of pedagogy in that with an explore, so look around, then learn, there's some application, and then doing an assessment module. So there's 3 components to the app. We were careful about it being an adjunct, so it was more about formative learning rather than summative. I mean, there is a quiz in there, but it's just to test that what they've learnt. I guess the value provides students as an adjunct, as a revision tool. And then the applicability we thought about was, is it just for medicine or can other people use it? Scope across disciplines, I guess. So we think about nursing, paramedics, that sort of thing. And then making it mobile was that students could use it anytime, anywhere. So you can download the app, and if you have a mobile device, you could access it anytime, wherever. So what we did is we introduced it to the students and then asked them to fill out a survey to let us know what they thought. A longitudinal project is to actually see whether or not it makes a difference to their summative scores and their results in exams. We're still working on that. We've just run our second survey a month ago because I only teach this once a year. But initially the students' response was very positive, ranking features in there that the 3D concepts were important, and that synchronicity between the ECG trace and the heart, as well as it's fairly real, but still only a 3D model. So it really helped understand their understanding and their confidence in it. They had some very good feedback for us, which was encouraging, which really showed us that the app was doing what we hoped it would. Not everyone was positive about it. There are some things that we've learned through the process about having a fixed marker. I'll talk about that a little bit more later. Some wisecrack students said, "Oh, this is just a project for staff to, get on their CVs," and I guess we want to do that as well. But that wasn't our initial motivation at all. Then we did a little word cloud, I thought, and one of the best responses and things, it's about it's engaging and fun, but also interactive, interesting, helpful, and they're learning. I guess that's a lot of what we got out of that. The recent session we ran, we had 50 students in a room and all using an iPad at the same time. There was quite a buzz around the place. It was very, we could see that the students were definitely getting into it and taking part of the assessment module just to see how much they were learning. Here's some data that was in our paper as well. Very high scores on aspects of the app. I guess it's about the questions you ask. But the idea is that, there's understanding, help learn in a new way. The app was fairly easy to use and motivated them, I think. That they use it again is important. I guess they're all revising for exams down the track, and very positive aspects of that. Some of the feedback we got too, though, was highlighting what we could change in a future version. Talking about staff experience as well, we have our clinical skills educators. We also have tutors who work in that area. They're casual staff that come in to help out with those sessions. It's great to be able to sit and talk to students. We did notice in our last one a couple of weeks ago that students actually found a mistake in one of our illustrations, and that's something we have to work on for next time. But just being able to discuss that with a tutor to I guess, validate and acknowledge that they found a problem, a bug in the system. It's good for us to acknowledge that their picking up that sort of thing for us that missed our quality control. The students can then ask for clarification on things, immediately. So if they're doing that in a scaffolded, supported environment rather than at home on their own, that's a really valuable thing our staff are providing. And then we noticed that students are helping each other. Not everybody is as tech savvy as we might think they are, and some obviously understand how things work better than others. It's quite interesting to see when you're using augmented reality or using a marker. It's not always as straightforward as some people think it is. And the collaborative aspect of it was really, really important as well, we thought, when learning together. Some of the implications of doing a project like this, it was a huge investment of time. I guess for everybody, there was setting up the whole storyboard and scope in the initial phase to think about how we wanted to do it. Lots of people involved. You can see that there. They were across different areas of the university. Particularly the cost of the development will vary in experience. So we were working with a vendor who probably had not done something as complex as this before, and we had to get them to come in to visit us in the school so that we could explain exactly how we wanted the animations to work and how to synchronize them. So that showed that it was very important you might document things, but it's not till you get down to the nitty-gritty of maybe even colour or shape of things that needs to be done. Thinking about the whole pedagogy design, using that explore, learn and assess methodology, we thought that was a good thing. And that for the students to really understand, being able to do that interpretation from seeing a 2D trace on a page to what's actually happening in the heart was important to try and get that right. I guess pedagogical implications, you can have something like this, but it's hard to squeeze it into an already busy curriculum. So how do you fit it in? We managed to find 20 minutes for the students to have a go with it this year. It didn't really replace anything. We managed to streamline the rest of the curriculum, like the introduction to ECG. Having tutors in the room with them was also really good to help them through and streamline their experience with it. So those sorts of questions about, how does it fit into the curriculum? Does it replace something? Is it extra formative or summative, standalone? And how much support do the students need? The platform that we do it on, the project was initially intended to be on both iOS or Apple and Android, but due to the developers' limitations, we couldn't get the Android version, which is unfortunate. The idea of anytime, anywhere, though, was very important, that they could download the app and use it whenever they wanted to. So the device-centric thing goes back to the platform. Do you have a standalone app that you can spin, rotate, touch, or do you have this augmented version is another question. We went to augmented reality because it was part of a Deakin augmented reality. Oops, don't know who's playing around with my slide deck. Probably because we made everybody moderators. I'll just get back to where we were. Having the augmented reality is sort of fun and whiz bang, but we've learnt from that, and I'll discuss that a little bit further along in my slides. So when we're thinking about doing this sort of project, how will it work? We needed to know what we wanted to do. I think that was clear from the outset, and we brought in stakeholders from across the university to help us understand what augmented reality was, how the app might work, how to build in the different modules. The people that came together was fairly serendipitous. I think we had Peter and myself in our eLearning team in the school. We had our subject matter experts. We had project management from eSolutions and our IT people at the university. And then we had the external vendors. It was tricky. The vendors were in Singapore, so it wasn't always easy. There was only a slight time difference, I guess, but to communicate with them, we found that we made much better progress when they came to visit us. We all learnt a lot. There are things that we wouldn't do again. We said how fascinating quite a bit. Didn't realise that, all sorts of things. Evaluating and testing took a long time. It was just as much time as building it. Often when you're doing a prototype, you can do the testing, and testing one thing breaks another. So we always had to thoroughly test all the way through. And that takes all of us. It's not just the project manager, but the subject matter experts are also taken away from their teaching and academic work to help do that. So we've learnt quite a bit through this. When we built the app initially, the assessment module was fairly fixed. We had 20 MCQs and they were static. So there's always the 20 MCQs. I guess you can go back till you get them 100% correct. But we wanted the developer to put in some feedback on that assessment to show the students what they got right. All they got at the end was how many they got correct. So it didn't tell them what was correct or incorrect, only that it was correct. And having only 20 questions, I think, that were fixed, I guess constrains the usability of the app. That's something we're looking at in a future version in another app called Oculus Sim, where we've got a bigger question database with a differential, levels of difficulty. And also, rather than getting the question correct or incorrect, if you choose the incorrect answer, it'll tell you that it's wrong, and it'll also reduce the capacity you'll get to score. So if you get it correct on the first go, you get 5 points. If you get it wrong on the first go, then the most you're going to be able to get is 3. And if you get it wrong again, the most you'll get is 1. And if you get it wrong again, you'll get 0. But then you'll know what the right answer is. So we're looking at that sort of system for our next version. The other thing we found that students didn't like, and we found that awkward as well, is that to use a marker, you need to hold the device over the marker at all times to be able to access the app. And in our later version, we're looking at markerless technology, which is now available. It wasn't at the time, but all you need is a flat surface, and you can say, all right, turn on augmented reality so that I can now see the model in 3D or in augmented reality, so it just floats on your desk rather than in the app itself. I've highlighted that idea of scope everything and get it documented. Very important to have everything nutted out initially, and in our new Oculus Sim app, we scoped that project and then sat down with the vendor to make sure that we all knew what the implications were of what we were doing, how we were designing the app and the pedagogy behind it. And the other thing we didn't think a lot about was, will we have version 2? And with the cARdiac ECG, it's a fixed app at the moment and there's no database behind it. So we're looking at seeing if we can redevelop it into making it a sister or a brother to our new Oculus Sim app, so that we can exploit the question database and use the markerless augmented reality. So I'm happy to go into a show and tell, but we'll just pause for a minute and take some questions, I guess. I guess folk could, for now, use their mics to ask that, or write it down. But I can see there's something there from Cheryl. Yeah, that's an interesting question. So is there scope to have an open exploratory tool? We don't have that. That's a very good idea. Something like comment on the quality of the trace recording artifact. Yes, what we probably would want to do is some sort of feedback survey with the students, but there's nothing in the tool that provides that sort of feedback. But I think that's a great idea, Cheryl. Yeah, definitely something we'd take on.
So
yes, go ahead, Cheryl. I can hear you.
what I meant more around the idea of, rather than having a question that you ask, having a graph that's open to interpretation, and so the questions that you ask are outside in the LMS or associated with the tutorial or something like that. So it's just things that can be interpreted rather than the question being asked within the app, if that makes sense. So giving the instructors who use it, or the tutorial groups who are engaging with it, or the students who are using it for different purposes. So just kind of opening that up and kind of giving it as a sandbox type tool, like here's some resources that you can play with.
Yeah, I guess with cARdiac ECG in the MCG, in the MCQs of the cARdiac ECG app, we do have there are some questions. There is interpretation because they have to look at an image of the heart, or but then they're like they are static responses. So there's no, I don't know, Cheryl, if you meant by going away to research and coming up with a longer response.
I mean, so I'm thinking that, and I apologise, I missed the start of it, but from a given graph, I could ask you the question of, is this a good quality trace? But I could also ask you, what disease do they have? And so the ability to have those different questions asked outside of the environment. So rather than this all being within it, that question is asked by a tutorial group, or that question is asked by a mentor, or that question is asked by a peer.
Yep. Yeah, I'm just trying to think how that would work. I guess you could do that, but would you be accessing the app itself then, or just trying to think, if you ask those questions, do they go back to the app to check it, or?
Yeah, so as you're working through the app, so it could, it's the idea of kind of having the question written somewhere, and when they're looking at the resource, they get to see the heart and the trace together and kind of make the connections. And this is week 1, so I'm just going to ask you if the trace is valid, but in week 4 I'll ask you what the trace tells you. So it's kind of that idea of, you can come back and reuse this thing for lots of different purposes, and different people will be looking at it for different reasons, and just by having that resource there as an academic, I get the control to ask this question or that question, or I can give all of you different tasks to go and engage with and come back with different answers. But just a thought.
No, that's a good one. I mean, it is very like it's a, I don't know, what do you call that, sandboxed thing, rather than an open tool. I guess once we go through the demo, you get to see how it's actually built and what might be possible or not. Barbara, you've said there, once they've mastered the recognition, it's their scope to go up the level and deal with treatment or interventions. We don't have that built in, not into cARdiac ECG. I guess what we've built into the new app we're working on, Ocular Sim, the Ocular app is looking at the eye, the globe, in the bony orbit, how it fits in the socket of the skull, and the different bones that surround the eye, the blood vessels, nerves and muscles that are all involved, which is also extremely complex. I guess the questions, what we're wanting there, students to learn the anatomy. So what blood vessel supplies which nerve, which innervates which muscle, which turns the eye a particular way. We have levels of difficulty in that. I guess it's not so much. I'm just trying to think. I really like the questions, though. Provoking lots of thinking on my side here, how we might work on a next cardiac ECG. But I like that idea of, I guess because we've got a set, the cardiac ECG is something you look through, but it's not as manipulable to show everything. So we have a set number of scenarios. I guess we could probably get onto that now. Notice the time's moving on. So thank you for, what's my slide deck? Oh yeah, there's questions there now, so we've been having those, I guess. What I have to do now is, I'll just get it up on the screen. The chat's still open, so feel free to ask questions. What I'm going to do now is share an application which is QuickTime. Now, hopefully that'll come up on the screen. I just wanted to get an idea from everybody if they can see that okay. There's a, yep, oh, that's great. Lisa was going to ask something, or Lucia? Oh, that's all good. So what's happening here, what we can see is I've plugged my iPad in to my laptop, and then just the best way to show that is via, to share that via QuickTime, starting a recording. So that's my hand there. This is the marker. So it needs this marker to work. If I pull that away, then you get a static screen and says, hang on, you need the marker to work. I'll slide back into view, and then this menu will come up. Yes, Cheryl, the app's available in the iTunes store. If you look for cARdiac ECG from Deakin, you'll be able to download it there. And you do need the marker. You can print that out, or you can actually have the marker. Oh, sorry, Cheryl, not on Android. It's only iOS. Our next one will be on both platforms. But if we redo cARdiac ECG, it'll be on both. That was one of the issues actually for us. Not all our students have iOS devices, so we had a class set of iPads for them to use. David, it's called cARdiac ECG, cARdiac space ECG, and you should be able to find it. Look for that. Look for that icon. So this is the menu, and I'll just tap on Explore the Heart and wait for that to load. The frame rate is a little bit less through Collaborate than it is on my machine, but I trust you're seeing that. So the trace, the blue grids with the pulse is a normal ECG, and that's synchronized with that beating heart. So now I can manipulate the marker and it moves the heart around. Sorry, I'll go slow. You'll notice that you can see the labels for parts of the heart. That's the other thing we wanted the students to learn. Now I can turn off the labels. There's a little menu at the bottom, so I can turn the labels off. I'll leave them on for now. The idea is that this is the Explore section, and if I go to cross section, so everyone who downloads the app can access this part. Once we go to the Learn and Assess, you need a code to access that. We've just had, it's taken a year, but we've just had approval to circulate that for free. So we just wanted it for Deakin students, I guess, but we never actually planned about a plan to monetize the app initially, and we were keen to share that with people as much as we could. We've had inquiries from all over the world about getting access to that code. We've talked to the solicitors. They're happy for us to distribute it. We just have to work out some sort of terms and conditions and an MOU as to distribute that. But anyway, back to the app. So we'll be changing the description on the App Store shortly to announce that how we can access the app. So I've gone into cross-section mode. You can move this mark around, and to get a better look at how things work, I can turn off the labels, I can turn off the blood flow, and then we can just see the electrical current flowing through there. So the idea that the students come to understand how all that works. I'll go to the Learn section now. So you'll need a code to get to this point. I might be able to distribute that at the conference later in the year. But part of this is we wanted students to learn the ECG procedure, to see some different scenarios, and to see how the leads work on a heart. So if I go to the ECG procedure, what we have here is some background to the waveform, how it works, going from to a positive electrode. If it goes away, it's a negative one. Students will read through all that. One of the things the students pointed out was the J point that's illustrated there is not actually at the base, it's just a little bit higher up with a horizontal line going to the right start. So that's one thing we need to fix. If we go, let's go, what we've got here is a little figure, and this is really showing the user where the electrodes need to go. So that's the left leg. If I tap on right leg, that shows where it is. If I tap on the right arm, it shows where that is. You can rotate this around. I could pick up the marker so we can get a good top view. There's this is the mid-clavicular line. It's an important landmark, I guess. We can just keep tapping where all these are. There's another line down here, 5 and 6. Now we can actually show the rib cage. This was an important thing we thought. What students need to understand is that these electrodes have to be in the intercostal space. That's between the ribs rather than on the ribs. Otherwise you won't get a good reflection. So we thought it was important to be able to display the rib cage. Then we go to, so this is the ECG procedure. Then we can look at the ECG scenarios, the different scenarios that we have. So there's the normal, it's called a sinus rhythm, and it's got a little bit of scaffolding at the top of the page there, normal heart rate between 60 and 100. So the important thing we wanted to have here, and this is something else we realised during the development, we do have a pause button, but it would have been much better to have a scrubber, which is sort of like you can just slide backwards and forwards through an animation rather than pause it. You can go backwards and forwards. That'll be something we do in the next bit. Lisa's asking, this part of the tool is hidden behind the code. That's right. So Lisa, we've made a code necessary for the learn and assess. So if you download the app, you'll get to go to the learn and it says please enter the code. We will be distributing that fairly shortly. I can't do that yet because we haven't quite finalised the documentation and how we're going to do it. If I turn off the blood flow, then we can just see the electrical current, and then if I hit pause, you can see where it's just paused in the middle of the heart there, and then you can see the trace is also paused. So if I hit it again and pause it somewhere else, you can see that it's now on the downstroke as it's causing those muscles to contract. So we found that that was a useful thing for the students to pick up. If I go through the scenarios at the bottom there, they just work through. So then now we've got a bradycardia, which is a very slow heart rate. I'll turn the blood flow back on so you can see it takes a moment to resynchronize with the trace. Slow one, then we get atrial fibrillation where it's all chaotic and there's no regular spark. Sorry, I missed the tachycardia, which is a fast one. So you have the matching trace as well. Ventricular tachycardia, which is way too fast. Ventricular fibrillation, which is it's chaotic, and I don't think you're going to survive that. And the last abnormality was sort of an acute myocardial infarction, otherwise known as a heart attack, and it just shows where the damage is occurring in the heart, and it shows the traces change now because there are things that happen minutes, hours, days, weeks, and months. How the trace changes. If we go to learn the ECG view now, because we've seen all that, this talks a little bit about, gives you a diagram. It says tap on a lead to see how it connects to the heart. So the idea was here we wanted to show what region of the heart the things look. David 2, no it doesn't. It's only, we've only just got the one there. It's a bit tricky because they're all different and you'd probably have to show quite a few, but thanks for your question. Might be something we could do in a future version. What this does is show us which view of the heart you would have. I hope I'm not going too quickly for folk. One of the students asked us the other week whether or not we could have different colours, because often the textbooks show all these things in different colours. Seems to be a standard way that each one's not different. We just wanted to make sure we could highlight what each one was. So that's, once the students have worked all their way through that, then they can go on to the assess module. I'll just tap that up on the top screen. So the idea in here is to enter your name. Oops. And I'll just put Colin. I can put my email in later again. But that's your email address so that we can send you the results. So we've got three parts of this. There's the quiz. Then you can perform the ECG and then label parts of the heart. So I'll just quickly go through that. So this then, the question at the top asks, oops, beg your pardon. This question asks which arrhythmia corresponds the best to this ECG rhythm strip. I don't know. I'll say it's one of them. What we want to do here is really to say whether or not that's correct, rather than move on to the next question. The students don't know if they're right or not. It doesn't give a result at the end. So I'll just work through these quickly so we can move on to the next bit. What was tricky for us in developing this was getting the traces. We actually used some Creative Commons ones, which are acknowledged at the beginning of the app, and I mean, it's hard to find. We found it difficult to resource the exact sort of trace that we'd want for the quiz, so we just ended up grabbing some of these from an open source one. Oh, hang on, where am I going next? Sorry. Okay, so here's some more. I'll just finish this off quickly, keeping an eye on the questions. Don't know if I've ever passed this quiz completely. Then we go, so that's the quiz done, then we perform the ECG, which brings us back to our figure. And then, so another shortcoming in this app here too is when I press on V1, it doesn't indicate that I've actually pressed on it. Cheryl, is answering the quiz tapping buttons on the iPad? Yes, so there's 4 answers there. I'll just tap on the one which I think is correct. So I'm just tapping on, I've just tapped on V2, and I'll tap on V3 and then touch the dot that I think it is, V4. I mean, I don't think many students get this wrong. Oops. We've got left leg, should be down here. Right leg, left arm and right arm. There was a fair bit of work involved in making sure the developers understood exactly where the placements of these were and getting them right on the inside of the shins or all that sort of thing. Now there's a, this is label the parts of the heart. Now this is also a tricky one to develop. How do you know which way do you do it? It says tap on a pin, then select the correct name. So I'll tap on that pin, it's turned blue. And now I'll say that that's the right atrium. That blue is the left atrium. And I'm just going to go random for the others. So this is more of an anatomy thing about the students understanding where all the bits are. And you can rotate the model to see things a little better, to see where all the valves are. I'll just finish that off. You can see how it works at the end. A couple left. So one thing we thought was good about this is that the students are actually having to touch something, to interactive things. So I'm viewing my results. And 29 out of 52, sure. Yeah, parts of that, I'm not very good at it. So if you're not happy with that, you can try again, or you can email your results, and I can, hang on, up here. We do have in there that you can, depending on what size you want to send, it's got a text version and an actual image of your results. It can be added to a portfolio. By default, we've added some ECG AR. In the terms and conditions, it says that we might use this for research. But you can delete that out. Students can delete that out if they like. And then they send that off and they're done. And then this is back at the home screen of the app when you first use it. Gives you a link to download the marker. It'll load a PDF. And if you do that on a phone, you can also use an iPad then to look at the phone, I guess. And tap to begin, loads the experience and then needs the marker to view it. So that's pretty well the demo. I'll stop sharing that screen and we can get back to some questions just before we finish up, if you have any. Thanks, Barbara, for your comment. So apologies that not available for Android, and but we do hope maybe our next version will have that. And if I present at ASCILITE at the end of the year, or when I do, we'll obviously have the code ready by then. If people want to duck in there, or if you want to contact me separately, I can make a note and send it out to you once we have that available. It's been quite a journey, but from what we've learnt, we're applying a lot of those things into our next app, the Oculus Sim. Barbara's saying, my experience is that very complex when building. We've had trouble with Android versions for Monash Rocks. Yes, it's with our new one, we've done it for Android first, and they thought they could just port it to iOS, but it's taken them a week and they're still not quite ready for that. So it is complex, lots of coding involved. Lisa's saying the marker best on A3 or A4, and Lisa, you can use whatever size. I'm using a half A4 today. So I've got 2 on an A4 page. What we found with the students, the bigger the marker, the bigger the model, the bigger the AR model. So if you've got some students sitting around a table and they've all got an A4, they have to sit back a fair way to see it. But you can also have a small business card size, and you get a bit at scale. So the smaller the marker, the smaller the model. But I keep a little business card size marker in my wallet. It's a great party trick I can pull out. Best size for a marker, I reckon half A4. Yeah, half A4. If you can get 2 on a page, that tends to work okay. A5, that's right. Yep. But if you download the PDF and just copy it, save it as an image, you can paste 2 on a Word doc page or something. It works in black and white as well as colour. We haven't quite worked out exactly where on the marker it reads, but yeah, that's great, Barbara. I don't think it's hidden in the logo. It's something to do with the little triangles in the image. Cheryl, the back end we're using for development for cardiac ECG, I'm not sure. We're not working with the vendor who built that app anymore, unfortunately. The new Ocular Sim app's done with Unity 3D. So we have, yeah, thanks, Barbara. It is Unity for our new one, and we'd probably stick with that if we redid what we've done with cardiac ECG. If we redo that one, we'd be using Unity again for that. Seems to be the best thing. Yep, I agree. So the vendor that we had, we weren't happy with the way they, every time we went back to them for a change, they kept quoting, you know, the original scope, and if you want something else, that'll cost you more money. And we really didn't have that. So that was a little tricky for us. So if we redid cardiac ECG, we'd use the basic foundation of what we've got, but probably rebuild it. Yeah, definite learning experience, but it's been good fun. I think seeing the students' response has been, you know, one of the best things. Fairly positive. In engineering and bioscience, yeah, very interesting, Cheryl. We did actually think about using asking like even IT students or someone who might have that 3D programming or AR stuff. I guess we're under the pump and had specific funding to what part of our new Ocular Sim project is to develop the 3D model, but also to develop the database for the questions. To have the new, I think we're calling it an experience management system, to hold all the questions, the answers, the difficulty, the relationships between all the parts, all that sort of thing. That's been just as much work as the model itself. And that's what we really wanted to do with this second app, is have that capacity in the back end. Gives us all sorts of analytics as well as, you know, what students are looking at, what they're touching, pressing, clicking on. It'll give us much richer data, I guess, on how students are using the app. Barbara, did you have a question?
Yeah, so I want to use the microphone, if that's okay.
Yeah, sure. Yep.
We also, you know, as you know, have built an AR app, and it was as complex as you said it is. And your app's fantastic. It's a lot more complex with AR than ours is. There was another project here at Monash that used students to help build the app, and it just was an epic fail. The students didn't have the skills. The developer, the project manager, spent a lot of money paying students for extra time. They couldn't manage the task, and so she then had to go to an external person or try and do it herself. So it seems lovely. I thought that we would try students with our app as well, but I just don't think that, if it fails, it's no big deal for them. They just write a report to say, oh, we tried and it failed. But in fact, we, like you, needed to have a product at the end because of the funding considerations, and it was just too difficult to get that to an appropriate conclusion, I guess.
Yeah, I guess it was a big project. I mean, we spent, I think I can talk about that, about 50,000 on cardiac ECG. and I'm going to guess that Oculus Sim will probably be double that, but
Yeah.
we'll have the whole database back end as well. I think
Yeah.
that'll.
We spent about 120 on our app, but we had a database as well. We had a big multimedia team. We had a programmer. We had 3 SMEs and a researcher. It was quite a lot because of all the information we needed to build in as well. But mostly multimedia and augmented reality just burns through money. You would have had.
Yeah, we've had some. Well, we had lots of sticky things with the original developers for cARdiac ECG, but we've even noticed with Optom that to get the model right, they make a change and they shift a nerve so that it's now joining in the right spot, but it's being pulled out from the other end.
Yes.
And we've got to go back and do all that. But the only people getting paid are the developers. You know, we're all doing it.
Yes.
For the love of it. And
yes.
but you know, we learn through it.
Yeah. Yeah. We found that with our multimedia too. They would get some of it right, and then they'd have to go back. And every time it was, it took a long time to get our figures correct. To get our, you know, we have an underwater environment. Just took a long time to get them accurate, like you with the heart, very complex. And that programming's terrible.
Lots of to and fro, that's for sure.
Yes.
But it's so interesting. One of the lead programmers on Oculus Sim knows just as much about the eye as our subject matter experts.
That makes it easier.
Yeah, he's learned a lot.
Yeah. No, you do. No, it was excellent. Your project's excellent.
Thanks. Yeah. Well, we hope Oculus Sim's even better. Yeah.
Yes. Yeah. We haven't looked at that. We're happy with Unity. It seems quite stable. But we've had the same issues with Android as well. It's just impossible to build for all those devices.
Yeah. Cheryl, you happy to explain your question now? I'm not sure if the 3D models can use the 3D printing models as a starting point.
So I know that there's an anatomist who's done a lot of work on getting MRIs converted into printable 3D models, so kind of 3D printing. So I don't know if you could use that data that's been converted into the 3D, like the instructions for printing, and use that as an input to Unity. So it's not a refinement, it's a starting point. So for example, next time when you move on to the knee, as a starting point, either that MRI data or 3D printing instructions. I don't know if that's a feasible starting point for it.
Well, it's
a good thought.
No, it's a great comment. What we did is our Simon, our optometry guy, was 3D printing the bony orbit. So it's just a little bit of skull that goes around the eye. And he was printing one for each student, 3D printing them, taking ages and ages, having to do 100 of them. And then the students had to colour in the different bones and thread wires through where the nerves and things go. And he used the model he had for that and gave it to the developers. But the model he used was way too big. It made, they had to dumb it down. There was like 7 trillion polygons or something. And it was much too processor intensive for Unity. Oh, not for Unity, but in the end to work as an app. And but that's what they did start with. But they built the eye from scratch, I think, and all the muscles. But used the bone MRI scan or whatever it was as a start. Yeah, it is intense, Barbara. He does. It's amazing what he does. We thought about trying to build the AR so that the augmented reality component of the Optom Sim would actually fit in an eye socket, or fit in their bony orbit print, their printed bony orbit. But didn't get around to that. Yeah. But I think we're up for time. I'm not sure if Andre is still on board, but oh yes, he's there. Appreciate everybody's comments, and thank you very much for listening, I guess. And if you're all at ASCILITE this year in Geelong, make sure you come and say hi. And if you're interested in the code for the Learn and Assess modules, please drop me a line, and we'll definitely get that out to you when we can. Yes, it is being recorded, Lisa. I'm not sure. I'm going to hit stop record shortly, and Andre will probably and make that available through the community, I guess. Yeah. My email address, if we just go back to the slide, it's Colin Warren at colin.warren@Deakin. I'll just see if we can get that slide back up. Why isn't that working? Oh, share now. Sorry, got to click that. Sit down to the end of this. colin.warren@deakin.edu.au. Should be on the screen now. Yeah, colin.warren@deakin.edu.au. If you want to send me an email. Yeah, thanks, Paul. It's definitely a teamwork job, and one of the good things about the project, actually, because it involved lots of different people doing lots of different things, and we all learnt from each other, I guess. Yeah, but it does take time. So thanks very much, everybody. Really appreciate the opportunity to talk to you, and if not, we'll see you at ASCILITE or online at some time. And Andre's saying he'll be sending a link to everyone for the recording. So thanks, Andre, for that. I'll press